We are from Group 11 for subject Intro to Mechanical Engineering. So for this video, we will be talking about water tank innovation. Okay, this video will be consist of problem statement, mind map, MATLAB coding, and the calculation of weight distribution.
Pada menaria, in problem statement, we will be discussing about the key factor in designing a water tank for a commercial building. There are several critical aspects to consider, which is volume, height, material selection, and weight distribution. First, let's talk about the volume. The new tank must have 10 to 20% larger than the old one. This increase is essential to meet growing water demand. However, overestimating the volume can lead to wasted materials and higher costs, while underestimating it could necessitate costly modification later on. Second, which is height. The tank's height should remain constant at 60 meters with a tolerance plus minus 0.3 meters. This ensure that the tank fits within the existing space while maintaining the structural stability. Another aspect is material selection. Material selection is another crucial factor. The material must be durable, strong, and corrosion-resistant materials. Where if we choose the right materials, it will prevent wear and reduce long-term maintenance costs. Another aspect is weight distribution. Weight distribution inside the tank is equally important, with holding capacity potential reaching 30 to 40 kN. Proper distribution of weight must be analyzed to ensure that the supporting beams can handle the load without compromising the tank's structural integrity. Finally, it's crucial that we avoid over-optimizing the design. Doing so could result in cost overruns. The goal is to strike a balance between meeting the required specification and keeping costs under control while ensuring safety and efficiency. That's all.
Okay, so I'm Muhammad Shami. So today I'll be presenting the weight distribution and beam design calculation for the water tank support structure, focusing on ensuring the safety and stability of the system. So the purpose of this calculation is to verify the supporting beams can safely handle the expected load from the water tank, which is from 30 kN and 40 kN. This step is critical to avoid structural failure and ensure uniform weight distribution. So now, let's go into the detail. Since the load of beam across the beam is 4 beams, each beam carries the portion of this weight. For the minimum weight, we use the formula W/N. So for the minimum weight, 30/4, and we get the 7.5 kN per beams. So and for maximum weight, 40 kN/4, and we get 30 kN for each beams. So next, we calculate the uniform load per unit length by using WL/L. For the minimum weight, 7.5 divided by 20, which is 20 meter, and we get 0.375 kN per meter for each beams. And for the maximum weight, we use 10 kN/20 meter, and we get 0.5 kN per meter. So this load is uniformly distributed along the beam, meaning that the radiation at both ends of the beam will balance the load and maintain equilibrium. So that's all.
Hi, I am Muhammad Arif, and I will present about the problem that using the MATLAB solutions. Okay, this is the MATLAB coding. First, we start by defining the parameter given in the problem statement, including the previous tank dimension, height tolerance, and desired volume increase range. And then we calculate the volume of the previous tank using the formula V equals to pi r square times hash. After that, we calculate the target volume range by multiplying the previous volume by the volume increase factors. Finally, we calculate the possible radius for the new tank using the formula R equals to square root V over pi hash and plot them against the volume increase percentage. So this is the graph that we obtained. From the graph, we got radius is equal to 7.34 meter for the minimum percentage increase. While for the maximum percentage increase, we got R equals to 6.67 meters. Moving on to the next question. So in this question, we were asked to find the bending moment and shear force using the MATLAB solution. So this is the MATLAB coding, and this is the bending moment diagram and shear force diagram. For the bending moment diagrams, the parabolic shape shows the beam bending under the tank's weight with the highest stress at the midpoint. This information is crucial for selecting the beam materials and dimension to prevent failure. For the shear force diagram, the linear variation indicates how the supporting beams react to the tank's distributed weight. The maximum shear force at the ends corresponding to the reaction force at the supporter. As we can see on the diagram, we got the highest stress is equal to 1500 kN per meter, while shear force is from 300 at 0 distance and minus 300 kN at 20 meter for the minimum weight. Meanwhile, for the maximum weight, we got the highest stress is equal to 2000 kN per meter, while shear force is coming from 400 kN to minus 400 kN along the distance 0 to 20 meter.
Hi, my name is Sarifana Alisha, and I will be explaining about the mind map. So we are choosing 3 different materials, which are stainless steel, polyethylene, and fiberglass. So for the stainless steel, we already choose a radius of 7.51 meter with a volume increase of 15%. The pros of this material is it has the advantages of high durability and corrosion resistant, which make it a long-lasting usage. And for the support weight structure, it has a stable support with a reinforced concrete base. But there are also some challenges for this material, which is it has a high initial cost and also a risk on the thermal expansion. Next, I will be explaining about the polyethylene. It has the key features of a radius 7.5 meter with a volume increase of 14.9%. The advantages of this material is it is easy to install and it has a lightweight material that require a minimum maintenance. And for the cons, it has a material limitation, which is a shorter lifespan, and also it has a lower strength than other materials. For the last material, we have a fiberglass. It has a radius of 60 meters with a volume increase of 8%. For the advantages, it has a low initial cost, good corrosion, lightweight, and strong material. But the challenges is the lower volume increase make it have a potential in leading to water shortage, and also a material defect. FRP manufacturing can have inconsistencies leading to potential structural weaknesses, leaks, and reduced lifespans. And for the inadequate support structure, it exposes the safety risk and requires a costlier price. Now, let's discuss about how the customer budget influences the choice of material for the water tank design. Okay, so for the customers with limited budget, polyethylene is the most suitable one because although it has a shorter lifespan and lower strength compared to the other material, it is ideal for moderate water storage needs. Okay, so for the customers who don't care about their budget, stainless steel is the best choice because even though the cost is a bit high under the other material, it has long-term performance. So in conclusion, the choice of material depends on the customer's financial. That's all from us. Bye!